revolutionary tilt-rotor aircraft lifts off like a helicopter and flies like an airplane, offering numerous applications that could change military and civil air transportation. Two pioneering design teams compete to deliver the next generation of light attack and reconnaissance helicopter with an avionics mission equipment package that redefines the ground rules for battlefield combat. The first new commercial helicopter in more than 10 years is approved for production, featuring a no-tail rotor anti-torque system. Two European companies jointly develop an all-new three-engine long-range helicopter for anti-submarine warfare and commercial transport roles. Other new helicopter designs and upgrades vie for position in a growing marketplace. And suddenly, it appears that the future of vertical flight is with us today, some 50 years after the first practical helicopter. When you consider where fixed-wing aircraft were 50 years after the Wright brothers, the advance of vertical flight is not far apace. In the face of supersonic transports, spies in the sky, advanced tactical fighters, and stealth bombers, why the 200-mile-an-hour helicopter?
I remember a good friend of mine and a very prominent designer, scientist in aviation asked, when would the helicopter go faster than the airplane? Do you know that? I said, yes, I know. The answer is never. When would the helicopter be more efficient than the airplane? Do you know that? I also said, yes, I know that. Never. But I said that helicopter will do a number of jobs which no airplane will do, and which in fact nothing else will do.
Helicopters put people and things where they need to be, precisely. They don't need roadways, waterways, or runways. They are mobile, versatile, and highly maneuverable. They appear where you least expect them and where you need them most. They are angels of mercy, yet lethal, powerful, survivable. And they come in a variety of shapes and sizes to do the job at hand, whatever it is. For the military, the job for vertical flight machines is more varied than for any other weapon system, more demanding, and more critical to battlefield success than ever before. What does the helicopter bring to the battlefield? The ability to move vertically, from rice paddies or rolling decks, to operate without depending on ground systems, to blend into the battlefield, to trade size and stealth for heavy lift, to bring fire to bear in devastating proportions and with unmatched mobility. Nick Lapos, a former Cobra pilot who flew combat missions in Vietnam.
The helicopter capabilities have advanced so much with today's machines that the Army is actually beginning to change its doctrine on how to fight a land battle to capitalize on those capabilities. The helicopter allows the land battle to progress by jumping over obstructions that otherwise would have stopped the land force, by taking positions that would have been untenable previously. In this way, the land battle has actually progressed to become a three-dimensional battlefield. Very similar to the way armor changed the land battle tactics from lines of battle, a one-dimensional battlefield, to probes in depth, a two-dimensional battlefield. The helicopter now makes that three-dimensional.
Because fighter aircraft move at Mach 2, the tendency is to think the battle moves at Mach 2. It does not. You still need to hold the territory to win, and that means moving men and machines on the ground. To take the ground, and to hold it. In World War II, the U.S. bragged it could move a division 50 miles a day in winter, an incredible rate of progress. Heliborne forces could move 50 miles an hour in a high-threat environment, moving an artillery battery, for example, several times in one night in bad weather. Moving, firing. Moving, firing. Put that firepower on the helicopter and you can move even faster. At 150 knots, say, or penetrate at 20 knots, knocking out tanks and protecting ground forces every inch of the way.
Today's attack helicopter is worth 17 tanks to the enemy. It's hard to believe, but a 17-to-1 kill ratio has been measured many times in combat trials. Today's helicopter is probably the best system for destroying the enemy's helicopters. Today's helicopter moves troops places that they would never have been able to move before, moves combat equipment at speeds that are unheard of before.
For all practical purposes, the emergence of the helicopter as a modern weapons system began in the Vietnam War with Bell Hueys. They were widely used for tactical assault, carrying troops directly into the battle area. But the Hueys were unarmed and extremely vulnerable, which led to a succession of armed Hueys carrying machine guns and grenade launchers at first, and then whatever weapons ingenious Army personnel could figure a way to mount. In the meantime, a new Huey derivative, the Cobra, was developed, which brought rockets into the fray, got to the target twice as fast, loitered longer, and delivered twice the firepower of the original Hueys. The Cobras were further upgraded with field and factory add-ons, but though they were less vulnerable, they had to fly high and fast and use steep dives to avoid enemy defenses. When shoulder-fired heat-seeking missiles were introduced, the Cobras dropped down among the trees and added infrared emission suppressors to reduce their vulnerability. Against newly arrived enemy armor, the Cobras added tow missiles to their growing arsenal. It was a continuing confrontation of measures and countermeasures, with several lessons learned along the way.
In order for today's helicopter to survive and win on today's battlefield, it has to carry its strengths, and that is adequate battlefield performance, ballistic survivability, low signatures, and excellence in nap-of-the-earth operations under adverse weather conditions. And of course, tracking and
Major General Andresen, LHX Program Manager.
I'd say the biggest thing that has changed with regard to tactics is full recognition that to fight effectively and survive in future conflicts, we must operate at nap-of-the-earth altitudes. Now, nap-of-the-earth is roughly defined as about 4 meters and about 40 knots, 4 meters elevation above the terrain, whatever the shape of that terrain may be. So you've got to get right down there in and around the trees or the foliage or the folds of the ground.
From Vietnam experience, it was also apparent that helicopters had a bigger role to play in the battlefield, and that although Cobra served above and beyond, it was time to design new advanced helicopter systems to meet new tactical requirements. The McDonnell Douglas AH-64A Apache, some 18,000 pounds of muscle, mayhem, and mobility. Cruise speeds over 170 miles an hour and a range of 320 miles. Enough power to handle the strain of nap-of-the-earth flying and single-engine hovering and maneuverability. Armed with 16 Hellfire laser-guided missiles, capable of destroying existing armored vehicles at a standoff range of 5 miles, well outside the reach of most light air defense systems. Or the Apache can carry up to 76 2.75-inch rockets. With either weapon comes a 1,200-round 30mm helmet-directed chain gun. A target acquisition designation sight system called TADS allows the gunner to find the target and lock on without looking out of the cockpit. A separate infrared sensor provides imagery for the PNVS, Pilot Night Vision System, key to the after-dark combat scenario. Both crew members are linked to the sensors by an integrated helmet and display sighting system, which projects an IR image on a small mirror before the pilot's eye and superimposes flight and target data over the image.
We have to be able to do everything at night that we can in the day, and that's to eat, sleep, shoot, move, and communicate. And if that means flying at treetop level, bringing 14 combat-loaded troops, or performing our reconnaissance, or engaging tanks out to the max range of a weapon system, at night we have to be able to do that, and it's this unit right now is prepared to do that.
We're not going to do a deep attack at daytime, of course, and that's when we're talking 30 clicks behind the flot. It's very important that we can go at night and be able to use the systems to their full potentials.
The Apache can take a 12.7mm armor-piercing incendiary, absorb a head-on crash at 20 feet per second, a vertical impact of 42 feet per second, and the crew will walk away.
The best thing about an attack helicopter battalion is the ability to go out very fast, if need be, go a long distance if need be, and kick some serious butt.
Paired with the Apache in U.S. Army aviation today is the Bell OH-58D Scout. Its job? Aerial reconnaissance and surveillance for air and ground forces. The Scout is the latest in the Bell Kiowa series of light observation helicopters. with an uprated turboshaft engine, new glass fiber composite blades, a variety of armament to defend itself, and a mast-mounted sight to see without being seen, a valuable asset, particularly for a number of scouts configured with heavy armament for the hunter-killer role. Among the new AVIs are an integrated multiplex cockpit control and display system, data link and secure voice, a laser rangefinder designator used to acquire targets for the Apache, Doppler and inertial navigation systems. The Sikorsky UH-60A Black Hawk, the Army's primary utility transport helicopter for resupply and troop insertion. With a cruise speed of 160 knots and a standard range of 320 miles, the versatile Black Hawk far exceeds Huey performance.
Go further faster. We can carry 14 combat-equipped troops, point A to point B, 10 feet off the trees at 140 knots in a combat environment. In the old days, the old helicopters could never get away with that. Plus, we've got multi-engine capability, so if we do have any kind of engine problems, we can still sustain flight to allow us to continue our mission.
For medevac missions, 8 troop seats give way to 4 stretchers. Up to 8,000 pounds can be hoisted in cargo slings to the battle area. 4 removable pylons can accommodate additional fuel tanks, extending the Black Hawk's range to 1,150 miles, allowing self-deployment across the Atlantic. It's a rugged machine with various offensive, defensive, and survivability features, and an interior lighting system for night operations. Rounding out the main elements of the Army Aviation Task Force is the medium-lift Boeing Vertol CH-47D Chinook, modernized from the fleet of CH-47A, B, and C aircraft, which first flew in 1961 and served mightily in a variety of roles in Vietnam. The new Chinook D can carry more than 24,000 pounds in hover at sea level, or 44 troops, or 24 stretchers, or any combination.
I believe the greatest value of the Medium Lift Helicopter Battalion is its versatility. We're known by the units that we support to be extremely willing to pull off any mission that they may ask us to do. They can call us day or night, good weather or bad weather, and we'll always be there to do what they need.
Meantime, the undaunted Cobra has continued its upgrade program into the 3rd decade, culminating in the AH-1W Super Cobra for the U.S. Marines. Close air support and armed escort with substantial improvements in performance and firepower, a far cry from the underpowered, overworked Cobras of the 60s. Key is the installation of engines with 65% more power than earlier models. With more improvements on the way, the Super Cobra is alive and well and thriving on new technologies as they come along. Like the proposed Bell 680 rotor with its fiberglass and epoxy resin hub, which eliminates complex hinges and bearings. Flight tests have shown the 680 system to provide aerobatic qualities normally associated with high-performance fixed-wing aircraft and almost vibration-free flight. For the U.S. Navy, familiar airframes hit the deck with different names and for different missions. The Black Hawk becomes the Seahawk LAMPS Mark III, a multi-purpose platform for anti-submarine warfare, anti-ship surveillance and targeting, search and rescue, medevac, and at-sea replenishment. Another version, the CV Hilo, employs a dipping sonar system and homing torpedoes to defend the inner zone of a carrier battle group against hostile submarines. The largest and most powerful helicopter in the Western world is the Sikorsky CH-53E Super Stallion, in service with the Navy and Marine Corps. The triple-turbine, 7-bladed heavy lifter can carry more than 16 tons, or 55 troops, 300 miles, farther with in-flight refueling. A mine-sweeping version, called the Sea Dragon, tows heavy anti-mine sleds faster, in higher sea states, for longer periods of time than previous anti-mine helicopters. Although we're still dealing in 1970 technology for the most part, with 1960 airframes still in service, it's apparent that today's helicopters can do more things better than ever before. Why? There are a number of reasons. Power is one.
But those engines consume less fuel, which means we have to carry less fuel to do a job, and there can be, therefore, more productivity to the machine in terms of pounds of other payload.
Improved aerodynamics is also a big part of today's helicopter advances, reshaping the fuselage, new rotor designs, and sculpting complex blade shapes of composites for optimal structural as well as aerodynamic advantages. There's less noise, turbulence, vibration. In the world of vertical flight, that's no small accomplishment. And with these improvements, the door is open to the kind of tactics that make the Black Hawk and Apache so effective. Beyond firepower, defensive hardness, and mobility, there is the dimension of time that enables a battlefield system to remain on station long enough to do the job. To be available to the ground commander 24 hours, day and night, in any weather. That's been a problem with helicopters past. But you can refuel in flight now, or fill up in the field at your local blivet. Safety and reliability. Many remember the helicopter as a complex contraption thrashing in its own turbulence. But those were first-generation helos, piston-powered relics that began life with wooden rotor blades. Almost 1/3 of the helicopters in service today are first generation. Reliable turbine engines have improved safety. So have simpler rotor heads, modular electronics, more automation and cockpit aids to support operations at night and in bad weather, simpler flight controls, autopilots, and redundant systems which earlier payload-poor helos couldn't accommodate.
A typical attack battalion operation in today's Army is a multifaceted operation. Let me see if I can describe what could be done. Let's hypothetically say that the mission comes out that the battalion has to move an artillery battery to a new firing position deep in enemy territory.
Mission. On order, Company A deploys from Fort Assembly Area Sabre along Air Axis Pine and conducts an attack into engagement area Ivan from battle positions 1 Alpha and 2 Alpha to destroy the 1st Echelon forces of the 21st MRD. Be prepared to conduct screen of 2nd Brigade's southern boundary from phase line Lisa to phase line Bobby. The scouts are going to lead out from Assembly Area Sabre along Air Axis Pine, sweeping Route Oak, and at RP1, Mr. Bates will move along the south route, which is Route Aspen, clearing it, and battle position 1 Alpha. We need to continue the attack into engagement area Ivan. Once Team Alpha is refueled, they will again return Route Aspen. When they're on station, we'll do a battle handoff, and Team Bravo will then move out Route Maple to get refuel at Texaco. We'll continue that until we're told end of mission, or we get relief on station by C Company.
To do is insert by helicopter in this location here, move over to the objective area, place it under surveillance tonight, assist in guiding in the helicopters tomorrow for the B Company mission.
The only problem I see, sir, is that for map reconnaissance, it looks like the LZ might be a little bit tight, so we may have to go with 2 ship lists.
Okay, for that coordination, we have the air mission brief laid on for the ground element and also the aviation element.
Sir, for the support of the air assault, we'll be using the attack helicopters as a screening.
Very well. And we arranged for communications between the ground element and the aviation assets, Lieutenant Burris.
So the attack helicopters are providing a flight route security, and they'll be on call at the LZ if Bravo Company needs them.
Okay, looks like we've got it squared away. Let's execute.
We'd find the battalion scouts would go out and look for a good place to put that battery. They'd look for enemy assets around the area and then bring in attack helicopters to clear the landing zone. engage the enemy if necessary, but at least secure it so that the troop ships would come in. Troop ships would be brought out, troops on board, to secure the landing zone. They move out at high speed and low altitude as necessary, creeping in at the very end until they landed in the landing zone and secured it. Once the infantry had taken the landing zone, transport helicopters would bring artillery and supplies and the artillery troops to man the guns. Those helicopter assets from the attack battalion go off to do another job. So what they become, if you will, is more than just a battalion operating in the field, but they become a force multiplier by allowing the land battle to progress at many more miles per hour than it would have with ground assets.
These exercises demonstrate the capabilities of the 101st Airborne Division, the unique tactical ability of this force to plan, deploy, destroy the enemy, control the land area, reorganize, advance and redeploy in rapid, flexible leapfrog fashion, and respond to whatever the mission dictates can be directly attributed to vertical flight technology. Although the foot soldier, the man with the rifle, is the ultimate battlefield weapon, the helicopter has added enormous mobility, firepower, and speed. And this tactical force can be deployed anywhere on Earth, day or night, in a wide spectrum of terrain and climates, in temperature extremes from Arctic cold to tropical heat. The evolution of helicopter technology and design in both military and commercial machines has made major advances in other industrialized nations. John Zugschwert, Executive Director of the American Helicopter Society.
The four major companies and countries that are involved in vertical flight in Europe, in no particular order, are Messerschmitt Bocal Blohm, MBB Helicopter Division in Germany. They're headquartered in Munich. In Italy, we have Augusta Aerospace International. They're a division of the greater Augusta umbrella in Italy. We have Aerospatiale in France, which is a division of the greater Aerospatiale aerospace company. And we have Westland in the United Kingdom. I think all four of them have seen, number one, what their technologies can provide to their area as a whole, Europe, for its defense. Also, they've seen what they together can provide to the rest of the world on an economic basis for exports of technology and capabilities. Where they started in being co-production entities, they've built themselves up into being considerable, technical, capable entities. They can compete with anybody in the world.
The Aerospeciale Super Puma, a medium-weight, all-weather tactical transport which can carry 22 troops or a comparable cargo load. It features powerful Turbomeca Mikola engines and an improved rotor system. An armed naval version of the Super Puma is used for air-sea warfare and anti-shipping. Also, from the French, who first armed helicopters in North Africa in the 50s, comes the Gazelle, a major weapons system for many countries, especially in the Middle East. A 4,000-pound machine, the Gazelle may well be remembered best for introducing the Fenestron, a small multi-blade fan-in-fin design that replaces the exposed tail rotor, giving power, aerodynamic, and safety advantages. A second-generation Fenestron is used in the Dauphine series of helicopters. A derivative of the Dauphine is used by the U.S. Coast Guard for short-range rescue. Originally a single-engine design, the French Dauphin today has uprated engines and a composite rotor system. The result is a high-performance warrior called the Panther. In Germany, MBB has produced well over 1,200 BO-105 multi-purpose helicopters for civil and military applications. The 105 pioneered small helicopters and fiberglass blades which give the aircraft high maneuverability. Sold worldwide, the 105 and the BK-117 are among the leading helicopters for emergency medical service in the United States. Introduced in 1983, the BK-117 is an intermediate twin-engine helicopter. Its design incorporates many of the proven B-105 features, along with an unobstructed 200 cubic foot cabin. In England, Westland Helicopters has designed and developed the Lynx series, one of the most versatile helicopters in the world, and one of the most agile, with roll rates exceeding 100 degrees per second and unmatched speed.
All companies have looked at variations in tip configurations for helicopters to, number one, reduce the vibrations on board the aircraft and to increase speed. Now, the people at Westland did come up with the right combination. In the British Experimental Rotor Program, or BERP program as they called it, a lot of people laughed at the acronym, but it did set the world speed record of 219 knots, 10% increase over what the previous record was that was established by the Soviet Union.
For the British Navy, NATO, and several other countries, the Lynx has proven extremely effective operating from small decks for virtually all helicopter shipboard roles. The jewel in Westland's crown may well be the EH-101, a collaborative effort with Italy's Augusta to produce a new utility helicopter for the 1990s and beyond. It will carry 30 passengers for airline operations. Or, in the military transport role, the EH-101 can carry 30 men ready for combat. Building on experience gained in manufacturing under license to American companies since the 50s and its own R&D efforts, Augusta developed the A-109, the first helicopter to be single-pilot IFR certified by the FAA. Designed for the civil market, the A-109 has had great success in corporate and EMS service. Several military versions have also been produced. An all-new aircraft dedicated to the day-night attack mission is the A-129 Mangusta, or Mongoose, a modern 8,000-pound gunship. It's a tough fighter that could become the NATO standard, maybe compete with the Lynx for the same market. The T-800 engine for the US LHX is also being evaluated in the 129. All of which has brought Italy, Britain, Spain, and the Netherlands to consider an advanced light attack helicopter using the A-129 as the starting point for its anti-tank, anti-helicopter, and scout roles.
where the market will demand a collaboration between two countries, it's going to happen because the market demands what those manufacturers are going to put on the table. Collaboration, cooperation, joint ventures, the capability to jointly produce has been one thing in the past. The capability to jointly develop is the name of the game today.
In the Soviet Union, the evolution of the helicopter has taken much the same path as that of the West. From general purpose, do-everything-in-one utility helicopters to specific designs for specific missions.
I think the Russians learned quite early that even when confronted with a less sophisticated air defense system than certainly they would encounter against the NATO or U.S. forces, here they became, I think, very vulnerable to Stinger or Stinger-type surface-to-air missile systems. And this caused them to revise the conduct of their tactical operations to go more to a nap of the earth or terrain flight mode.
They learned the same tough lessons that we did in Vietnam, and it reinforced our understanding of the need for adequate aircraft performance, larger engines, if you will, for better ballistic survivability, and for better reduction of the signatures, for better, for instance, IR reduction.
Soviet response? The Mi-28 Havoc, their first gunship dedicated to the attack role. With no troops to carry, the Havoc takes on the slimmer look of an Apache with a reduced cross-section and much improved maneuverability over the Hind. Along with the Havoc gunship, the Soviet Chemov Bureau has designed the Hokum air-to-air fighter. Hokum represents the latest Soviet response to changing battlefield tactics. For many people, the civil helicopter appears to be little more than a flying taxi service, traffic, and weather watcher. But to others who know better, it's a whole lot more. A jack of all trades, a common transportation tool for the most unique applications. For search and rescue, it is man's best friend. Proven in battle by quick response and being able to get in and out of areas only a helicopter could reach. And proven, day in and day out, in countless places and situations throughout the world. It is estimated that helicopters have been instrumental in saving over 2 million lives. That's 50 lives for each of the 40,000 or so helicopters flying today. Where do we go from here? Well, pilots of the future are already preparing for the next generation of vertical lift machines. Unencumbered by memories of helicopters as they were, these youngsters deal only in Blue Thunder and beyond. The U.S. Army will have no trouble in recruiting pilots for the all-new, high-technology LHX. Designed to provide the battlefield commander with the support he could only wish for in the past.
It will provide him with certainly mobility, which is characteristic of helicopters. It will provide him with firepower. It will provide him with sustainability. It will be able to conduct operations at greater distances and acquire information much more rapidly, certainly, than the OH-58s can do today.
The significance of the LHX
Lewis S. Cotton.
First of all, is it gives him the capability of operating day, night, adverse weather, and areas of limited visibility. In addition, the survivability features gives the combat commander the capability of going deep to interdict the enemy without being seen or heard. It also gives him an armed reconnaissance capability to be able to recon by fire as well as recon in a stealth kind of an approach.
And because potential adversaries recognize that the most effective defense against the helicopter is another helicopter, the LHX is designed for air-to-air combat.
Will there be aces in helicopter air combat? Yes, there will. Will they be white scarf and goggle guys going out looking for other helicopters? Probably not. Helicopter air combat tactics will be vastly different from fixed-wing fighter tactics. The helicopter lives and works in a different world, and the helicopters it hunts also live in that world. It's a cluttered world, a nap-of-the-earth world that involves short stretches of intervisibility and a highly lethal terrain because weapons can go much farther than sensors can. So what we'll find is helicopters probing around the nap of the earth will engage in short, vicious battles. that the maneuverability that's applied to the helicopter will probably be that necessary to hide behind obstructions or to turn quickly and get your shot off. And probably not to have protracted battles that involve aerobatic maneuvers and vast turning circles in the sky before a kill is achieved.
Engines for the 10,000-pound LHX are two Allison Garrett T800s, which offer up to 40% more power for engines this size. And simplified field maintenance that requires only 6 simple hand tools. No major accessories take more than 6 minutes to replace. Alan Haggerty.
LHX will in fact have 60% less maintenance than today's current fleet. This will be accomplished through a series of automatic fault detection and location systems that will enable the maintenance mechanic quickly to identify what the replaceable component is. Modular replacement of components will enable these components to be replaced in the field, and those components will be returned back to a depot, thus eliminating what the Army currently calls their intermediate level of maintenance.
The composite LHX rotors will be either the 4-bladed Bell 680 bearingless system now flying on the Supercobra, or a 5-bladed, high-speed, all-composite articulated rotor system using elastomeric bearing technology. The Sikorsky-Boeing team is also considering a bearingless design. 2 designs are proposed for the LHX anti-torque system. In the Sikorsky-Boeing LHX, a fan and fin design similar to the Aerospatiale installation in the Dauphine and Gazelle is designed to improve safety and protect against ballistic and terrain obstacles, a particular concern in flying nap of the Earth. The McDonnell Douglas Bell team proposes a no-tail rotor system called NOTAR. Demonstrated on a modified OH-6A Cayuse, it is the first practical system to abolish the tail rotor entirely. A highly efficient variable pitch fan forces low-pressure air into the hollow tail boom, where the air is vented through slots along the right side of the boom and through a thruster at the end. The slot-vented air provides approximately half the anti-torque control needed in hover, while the thruster gives the remaining anti-torque required, as well as added directional control. Chan Morse.
The concept itself is not new. People have been working for years to get rid of the tail rotor by putting a thruster on the back of the helicopter, and when they did that, they paid a power penalty, and so that had to be addressed. The external aerodynamics of NOTAR, the problems involved there had to be solved. In other words, the tail boom flies like a wing under the main rotor downwash at low speed, so there was a lot of work done in that area to make that work. The thruster efficiency itself had to be worked on. The fan is a different fan than we've used in the past, and we had to develop techniques and design solutions to increase the efficiency of the fan. It's easier for the pilot to fly. He's able to operate in wind conditions he's not been able to operate in before, and he doesn't have a rotating mechanical device on the back that runs into things and that people run into from a safety standpoint.
Many technologies come together in the LHX, technologies which will become common to many of the new breed of aircraft entering the 4th generation of vertical flight. Very high-speed computers fuse the electronic and avionics systems and sensors that form the mission equipment package, the brain and nervous system of the LHX. A so-called glass cockpit provides information that previously required 100 different instruments or more. The LHX will use a computer-controlled, triple-redundant fly-by-wire or fiber-optic fly-by-light flight control system. The LHX will also be equipped with a suite of laser, chemical, and infrared radar detectors. Smart jammers will enable the LHX to protect itself automatically by confusing enemy infrared and radar-based weapons. An infrared sensor that looks at heat energy, and an advanced TV sensor that intensifies the light of the moon, the stars, or sky irradiance will enable the LHX pilot to see in the dark. Images from both sensors are presented on the pilot's helmet-mounted display and sighting system. The LHX will employ a deadly array of Hellfire and Stinger missiles, 2.75-inch folding fan rockets, and a helmet-directed 20mm turreted cannon. 90% of the LHX will be composite structure, which is being developed in technology demonstrator aircraft such as the all-composite Boeing 360.
The LHX is as good as it gets for helicopters. For a combat helicopter to do reconnaissance, deep strike, and work in mid-intensity conflicts and above, it is as good as it gets today. There are faster helicopters, but speed is not the requirement in the battlefield. Combat is the requirement. Most of the speeds are lower. Most of the ranges are 60 kilometers, and the day-night operation is what we're really looking for.
For the LHX evaluation, there will be no fly-off. Simulation runs will be used in great part to determine which of the two proposed designs best meets the needs of the United States Army. The Army expects to know how the LHX performs long before it actually flies. The V-22 Osprey, the world's first production tilt rotor, with a full mission range of 500 nautical miles and a cruising speed of 275 knots. Built under Navy contract to a Bell Boeing team, the V-22 could be the single greatest impetus to vertical flight since Sikorsky's dream began over 50 years ago. Concepts proven on the XV-15 research demonstrator. Hovering and moving side to side, forward and back, in its helicopter mode. Then, a simple cockpit control actuating screw jacks at the engine nacelles to tilt them from vertical to horizontal converts it into an advanced turboprop. Troy Gaffey.
There are three enabling technologies for the V-22. The first is tilt rotor technology. That is, making a tilt rotor aircraft that has the proper dynamics, vibration, flying qualities, and so on. Aircraft characteristics, if you will. We learned how to do that using the XV-15 under the NASA program. The second enabling technology is composite materials, namely carbon fiber materials. In the V-22, we have about 10,000 pounds of carbon fiber material that comprise the structure of the wing, fuselage, empennage, and the control surfaces, as well as the rotor hubs and blades. The third enabling technology is fly-by-wire. We have a triply redundant fly-by-wire system on the V-22. The wires are separated, as are the computers, so that we can take a ballistic hit in any one of the three, or for that matter, any two of the three systems, and keep on flying.
Civil applications also hold high promise for tilt rotor technology to help alleviate airport and airway congestion for business and commuter airline transportation. Using the V-22 as a baseline, studies show that with an airline-type fuselage, a tilt rotor could carry 36 to 44 commuter passengers more cost-effectively than a conventional helicopter and 2.5 times faster door-to-door. Meanwhile, 6 European companies in 5 countries are developing a technology concept for a 30,000-pound tilt rotor to carry 30 passengers plus crew. Dubbed the Eurofar, the McDonnell Douglas MDX, an 8-place, light, twin-turbine design grossing 5,400 pounds, features the NOTAR anti-torque system and an integrated glass cockpit compatible with night vision goggles. Among other vertical flights to the future are the NH-90, a 20-place utility helicopter to meet European NATO requirements. The PAH-2 anti-tank and support escort aircraft, the first joint development of MBB and Aerospatiale, and military and civilian versions of the ongoing EH-101. And the research continues, for the unique mobility and versatility of vertical flight machines are the stuff that continue to drive the dream. The advancing blade concept, for example, which employs 2 counter-rotating blades on a common shaft. And there is the X-Wing concept, a 4-bladed helicopter-like rotor system for hover and low-speed flight, which stops at about 200 knots to become a fixed-wing-like airfoil for supersonic speed. Computers, high-temperature composites, and circulation control aerodynamics blend in this research vehicle, which could presage the perfect flying machine. It's a research dream right now, but that's how vertical flight started in the first place.